The reference angles are sketch angles of 71 degrees, 133 degrees, 254 degrees, and 317 degrees in standard position, and calculate the measure of each reference angle. So we have to start this by drawing at least 4 Cartesian coordinate system axes here. Okay? And take note that they are starting from a standard position. So for the first one, we have 71 degrees. So that means the angle is in between 0 and 90 degrees. And this is always our 0-degree position. Okay? This is our 180-degree position. This is 270-degree position. And this is also 360-degree position. Okay, these are true for all angles. Okay, this is 90-degree position. So as you can see, 0 degrees and 360 degrees are also coterminals. Okay, so let's start with 71 degrees. So a 71-degree angle is in between 0 and 90 degrees. So meaning that the angle is somewhere here. Okay? So let us draw the angle. So it's here. Okay? Because the theta, okay, it's in its standard position. It's in its standard position. Okay, so then our theta here is equal to 71 degrees. Okay, but it says that the reference angle is the angle along the positive horizontal axis and the terminal side. Okay, or it's the positive acute angle between the horizontal axis and the terminal side. So in this case, as you can see it, the reference angle here would be from the positive acute angle. So we can get this one because this one is not acute anymore. So therefore, the angle itself and the theta ref are coincident. Okay, so the theta ref is also 71 degrees. Did you understand? Okay, I hope you get that. Now let's go to 133 degrees. So I think we did this a while ago with the lecture, but let's do it anyway. So 130 degrees invites that the angle is between 0 and 180 degrees. So it is from here, because it's in a standard position. So it's here going to this position. So let's draw the terminal side. So this would be the terminal. This would be the terminal side, right? Okay. So because that's the terminal side, our theta is equal to 133 degrees. But what about our theta ref? So this is 100. Okay, this is 133 degrees. I'm sorry about that. We have the theta ref would be from here to here because it's a positive acute angle from or in between the horizontal axis and the terminal side. So this is our theta ref. And our theta ref here would equal to be 180 degrees minus 130 degrees. Alright, correct. So our theta ref here would be equal to 47 degrees. Okay, so this theta ref here is equal to 47 degrees. Okay, next we have 254 degrees. So 254 degrees is in between the 0 and 270 degrees. So it's from here up to here. So forming the angle from a standard position, we will have something like this, okay? And our theta will be this. So our theta, this would be our theta, and that's equal to 254 degrees. But what about our theta ref? Our theta ref is the acute angle between the x-axis and the terminal side. So this is the terminal side, this is the x-axis. This would be our theta ref. Okay, take note that our theta ref is always counterclockwise. Okay, so the answer for theta ref would be 254 degrees minus 180 degrees. Okay, and that will give us 7. So 74 degrees. Look, it's an acute angle. So all theta ref are acute angles. Okay, so theta ref is equal to 74 degrees. How about the next angle? Our next angle is 317 degrees. So 317 degrees, of course, is in between 0 and 360 degrees, or 270 and in between, more likely 270 degrees and 360 degrees. So getting the angle would be somewhat like this, right? So this is 317 degrees. So let's sketch that. It would be here. So our theta here would be our theta, which is this, okay? Theta is equal to 317 degrees, and our theta ref would be this angle here. So theta ref. And this theta ref is just equal to 360 degrees minus 317 degrees. So that's equal to 360 minus 317. That would be 43 degrees. Right? So this is our example for sketching reference angles as well as the main angles thetas. Okay? So don't be confused about the reference angle. If you want to get the reference angle, make sure that first the angle is acute. Okay? So the angle is acute and positive. Okay? When you say positive, it's always a counterclockwise. The angle is always from a counterclockwise direction. Okay, number 2 is it is between the terminal side so between the terminal side and the horizontal x-axis and the x-axis or the horizontal axis. Okay, so these are the two things that you need to consider when you are dealing with reference angles. Okay, so this completes our example number 1. We could move on to example number 2. Example number 2. Sketch an angle of 4897 degrees in standard position and calculate the measure of the reference angle. Wow, this is huge of a degree. Okay, so it's a bit huge, but don't worry about that, because as long as we understand what reference angle and standard position is, then we could answer this question. So for 897 degrees, how do we start then? Okay, so let's label our, this is our 0, 180, 270, 90, 360, and so on and so forth. Okay, so how do we start? Remember that, angles are always, you remember the coterminals, right? So a coterminal angle could be from the least angle to a very big angle. So in other words, if we divide the given degrees by 360, then we could get the remainder, okay? And that remainder would be added also, and that's where we begin. The simplest, okay? When we get the simplest, then we will know where to begin our angular sketch, okay? So first we have to divide 4897. So 4897 degrees divided by 360 degrees. And what will it give us? That will give us, so that's 4897 divided by 360 degrees. That will give us around 13 revolutions. Okay, so 13 revolutions. So meaning 13 360s. Okay, this means that we have 13 360s. Okay? So what are we going to do with the remainder? What is our remainder, by the way? Our remainder is 217, right? So 13, the remainder is 217 degrees, right? So we will begin by plotting the 217 degrees. Okay? So okay. Where is 13 revolutions? Okay, we're going to sketch it anyway. So we'll just, if we want to sketch it, then we're just going to complete 13 revolutions. Okay, let us count. This is 1, 2, 3, 4, 5. As long as I reach here, I stop, okay? 6, 7, 8, 9, 10, 11, 12, 13. Phew, okay, that's so much, okay? And now we have a remainder of 217 degrees. Okay, so we will also plot that. So let's use another color. I would like to use blue. So 217 is in between 270 degrees and 180 degrees, right? So my 217 degrees would be, okay, let's just put it here, okay? It doesn't matter anyway. Okay, not good, okay. What if I erase these things here and then put him somewhere? So because this messes up the, okay, this messes up our sketch. It messes up our sketch. Okay. So I'll just compute it here. Okay, so first we have, I'm so sorry about that. So 4897 degrees divided by 360 degrees will give us 13 revolutions, or 13 360s. Okay? And then the remainder is equal to, what is the remainder? 217 degrees. And that's what we are trying to graph here. So now I will just, connect all of the messed up, connections here, the curves. Okay. Now I'm going to plot my 217 degrees. Bear with me, okay? This is 90, 180, 270, so it should be here. Okay? This will be our 217 degrees. Okay? So of course I will take my vertex from the origin going to here. Okay? So that is my angle. So now where is my reference angle? Because it is positive and it's acute, my reference angle should be here from this axis to here. Okay, this is my theta ref. Okay? So what is my theta ref? To compute for theta ref, that is actually 270. That's 270 degrees. Or let's say, what do we have? 217 degrees, I'm sorry. 217 degrees minus 180 degrees. So that will give us a value which is 7 and 3. So 37 degrees. That is the value of my theta ref. Okay, so 37 degrees. Okay, so I hope this gives light to your questions. So this is our what do you call this? Theta ref. Okay.